Okay, let's see this example here. It says a body of mass 500 grams is moving with a constant angular speed of 5 rads per second in a circular path of radius 4 meters. Find the force acting on the body towards the center. So in simple terms, if you have to make a simple sketch, you are having a body moving in a circular path. This is our circular path here. So this is our body. It has mass, so it's that its mass. We first convert it to kilograms, so the mass, which is 500 grams, which is equal to 0.5 kilograms. So it's moving in a circular path. So of radius, they are giving us this radius as of radius 4 meters. Now they are giving us that it's moving at the angular speed. Now they are giving us the speed. The angular speed as 5 rad per second. Now they want us to find the force acting on the body towards the center. So they are asking us to get the centripetal force. So in simple terms, we know that always. So now they are giving us angular speed. So they are giving us our formula there. So there, the only formula we are going to use is F equaling to okay, I think they will try to direct mr angular speed given that square. So we have the mass, we have the radius, then we can determine. I think you know how we got to this from this squared, from m equaling to mass times acceleration, but acceleration is v squared over r. Putting it here, they put the angular velocity in terms of the velocity. That's the ideas. R velocity is going to be now 0.5, then times r radius, which is 4, then times our angular velocity squared. So here our force is going to be, this is 2 times 25, it's going to be 50 newtons with ease. So that is just a simple sketch. A car is moving in a circular path of radius in a corner at the maximum speed of, so they are giving us a maximum speed of 28 meters per second. I think remember the case when we had maximum speed. Find the coefficient of friction between the road and a car. So this is the idea. We have a car here. This is our car. It's moving, of course, I think as it's moving in a circular. So this is the path this car is making. So that's the path this car is making. Now, they are telling us that the radius of that path, where that car is, which that car is making. I want to rectify something small here. So this is going to be our car here. So we're going to be having our car there. Of course, this car, because it has weight, it's going to be having the reaction because it's in the road. And then it's going to be having a weight of mg. Okay, from there, I think that's the radius. And the maximum, the radius is 100. So from here, up that car, there are 100 meters. So this is the path it's making, but it has radius, of course, from a certain center, which we are going to call that's the center of our circle. Okay, it's moving at the maximum speed, so this car is moving. Now we start here, they are giving us now the linear speed. Because of the units here, we saw the units were in rad per second, meaning this was angular, but this is meters per second, meaning it's a linear velocity of 28 meters per second. So that's the speed at which it's moving. Now, they're telling us that find the coefficient of friction between the rod and the car, meaning the force that is going to keep this car towards the center is going to be the F equal to mu r. This is how we give our friction. Okay, from there I always know that R always R force. The horizontal force is going to be equal always the mass, the centripetal force, V squared over R, where this force is always the force towards the center. Now this force is going to be this type of friction, it can be tension and so on. So this force now is going to be the frictional force between the rod and the car. So from here, this is going to be our mu r equaling to mv squared over r. Now, you know that our r from here, if I solve upwards, you can start my r is going to be equaling to mv. Why? Because there's no any other force acting vertically. This is moving horizontal. Of course, the rod is horizontal, so it's moving around. So meaning this is going to be equal to that. So if I substitute there, I have now my mu mv equaling to mv squared over r. So you see, if I cancel that, so that now my mu is going to be v squared over r times d by divide. So if you can ably substitute from here, ably see, now our v is going to be 28, the whole squared, then times the mass. Our mass, I think we still don't have anything like mass because it has simplified. So we have V, then the whole over our radius, which is from here, I think you can see that our radius there is 100. So 100 then times 9.8. And so from here, our mean is going to be 28 divided by 9. So this one is going to give me 0.8. That is the case there. As simple as that. Okay, the next here we have a particle of mass 10 kilograms. A 10 kilogram mass body is attached at one end of the string at one end of a lightning extensible string of length 4 meters being rotated in a circular path at a constant speed of 4 kilometers per hour on the smooth surface with the other end of the string fixed at C. Find the tension in the string. Okay, so this is the case. We have a particle, its mass is 10 kilograms, the length of the string is 4 meters, so it's being rotated on a horizontal surface. I think you can see that. So the tension now, the force that is going to be keeping this towards the center, I think this is going to be our center. So the force that is going to be keeping it towards the center is the tension in that string. In simple terms, if we are to make that simple sketch also, I'm going to be having it here. This is going to be the idea. We are swinging it, it's being rotated in a circular path like that. So it means that this is our body. This is our center where it's fixed at point C. Then it's being rotated. Telling us that this string, remember, when I rotate, it's the length of the string. When I rotate, I think you can see. It's the length of the string that's going to make a radius if I rotate. So if I rotate like this, you see that the length of the string is the one which is making the radius of that circle. I think you can see that. So meaning, the radius, now from here to here, is going to be now the length of our string, which is 4 meters up to there. But remember, it's the tension that is going to be pulling this towards that. Now, this particle, of course, because it's resting on a smoother surface, it's going to be reaction, having reaction. There's going to be reaction because of the contact on the surface. And then we are going to be having our weight as the mass times G in that order. So, that's what we are rotating around. So it's moving at a velocity of 45 kilometers per hour. So what is the first thing that we are going to do? We are going to convert this into meters now per second because you see our limit is also in meters. So our V equaling to 45 kilometers per hour. This is the same as 45. Every kilometer as 1,000 meters. per hour. It means that we are dividing with an hour. But every hour is having 360 seconds. Now this one is going to be in meters now per second. And we calculate that. You see, we are going to be having 450 divided by 35. I'm going 36.12.5 meters per second. So that is the case. Now, this is the tension. It's going to be equal to our force. It's going to be now the force that is keeping it towards the center is going to be now our tension. And we say for every force we have in the horizontal direction, it's going to be equal to the mass times the velocity squared over r. It's going to be equal to the centripetal force. That is the force that is going to keep it towards the center of that circle. Any force, whether friction, whether centripetal force, whether tension, has always to be equal to the mass times the velocity over the radius, because it's going to be accelerating in that. Alright, so our tension here is going to be equal to, we have the mass. Our mass is 10 times the velocity, which is now 12.5, the whole square over the radius, which is 4. So from here, our tension is going to be I'm having 390.625 newtons. So that's going to be the tension in a string. This is my part A. Then my part B, they want me to get the reaction of the part on the surface. So that now if I resolve part type, that my R is equal to 10 D, which is going to be 10 times 9.8. It's going to be 98 newtons. That would be the answer. So that's what we had in this lesson. I wish you well. This is a very circular motion. Everything is direct. So next example, we are going to see ideas of simple pendulum. Don't forget to subscribe to the channel. See you there.